to today's lesson. Continuation of the last lesson on section 4.1, image formation in eyes and cameras. Today will be lesson number 2, and today we will be focusing more on the eye, the human eye, in terms of technologies that's related to correcting vision problems. All right, so today's objectives. You must be able to describe the function of eyeglasses. Okay, so we know it's to correct vision, but what kind of vision defects could we possibly have, or do humans have in general? And then how do we actually do this? What kind of lenses do we use? So number 2, that leads into number 2. Describe when we use convex and when we use concave lenses. Okay, there's specific situations when we'll use them. And then lastly, we'll describe how night vision goggles work to enhance human vision. So we can wear, I'm sure you played many video games where you play a character that puts on night vision goggles and images probably appear to be green and that you can see way better with them compared to not having them in a video game. Same thing, they are based on real technology. All right, so when we're talking about correcting image problems with lenses, there are two fundamental basic issues that humans have with their eyes, and that is one of farsightedness and nearsightedness. There is also astigmatism, and we'll talk briefly about astigmatism at the end. But these are the two that I expect you to know the best, and that's what I'll be assessing you on. So they fall in two categories. Number 1, farsightedness. This is where people cannot see close objects clearly. Okay, so in a situation of a normal eyeball, light comes in, so very distant objects and close for that matter, light comes in and everything focuses on the retina as per normal. This is a normal light bulb. This is a normal human eyeball. Remember, just a review from our last lesson, this is the cornea out here. This is the lens, and both of them will allow refraction of light for the image to focus on the retina at the back. Now with farsightedness, you'll notice that the focus point is actually located behind the retina, and that is why this image that ends up forming here is obscure, blurry, okay, because that image is focusing crisply behind. Number 2 is nearsightedness, and of course you can see the normal eyeball again, but nearsightedness has the opposite problem. Here we have the light is focusing in front of the retina, and so you get the light rays are diverging at this point, and again you have an obscure image or diffuse image on the back. So if we need to move this point further back. So how do we correct this? Well, with people that are farsighted, you can't see close things clearly. So, and remember the image was falling behind the retina. So we need technology that will allow us to bend light faster or to cause it to bend sharper. And so we can do that by putting in here a convex lens. Okay, so it really shows out on the outer portion here that is convex, and it likely is partially double convex like we'd see in most textbooks. All right, and then here you see that in nearsighted people where they are having problems seeing things that are far away, we need to cause the light to diverge a little bit before hitting the lens, the cornea and the lens, so that instead of focusing up here, it focuses now back on the retina. Okay, so you want to use a concave lens to correct nearsightedness. You want to use a convex lens to correct farsightedness. Okay, I have a little video that's attached to the presentation as well. I really recommend you have a look at this. It does a great job and great animations that explain farsighted and nearsighted behavior and the corrections that we take. Okay, I did say I was going to talk about astigmatism a little bit before we get into eye surgery here. And really what it comes down to, it's astigmatism, is that the cornea or the lens is irregularly shaped. So it's not as straightforward as nearsighted or farsighted. In fact, sometimes it can be actually a little bit of both. And so you still use corrective lenses, but they are specifically engineered so that they can deal with what parts of the eye are farsighted and nearsighted, and they are very specifically engineered and tailored to that individual's type of astigmatism, to basically the misshapenness of their eyeball. Um, One thing to make note here with astigmatism, even though it is corrected with regular lenses like what I'm wearing here, I have a part astigmatism as well. I am mostly nearsighted. Well, I am nearsighted, I guess, but I do have astigmatism that even with my nearsightedness, it's not that easy. I remember when I was young, I had to have specially created lenses. They were a little bit thicker than the other kids to correct for astigmatism. Nowadays, my lenses are just as thin as most people's lenses, and you wouldn't even know unless I told you. Okay, and then I guess another technology now, and we'll lead into it here, is laser eye surgery. And this is where surgeons actually use lasers to reshape the cornea of the eye. Remember, the cornea is the clear shield or flap of tissue over top the outer portion of the eyeball. And that is the part that they actually reshape. Okay, they can get rid of those defects, if you will, or smooth out the shape so that it's a little bit more regular shape. And that will actually act as the corrective lens now so that the image is focused on the retina at the back of the eye. So that's pretty cool. And technology has come a long ways in that regards. Can't remember exact costs, but my sister had this done only a few months ago, maybe a year ago at the most. And she got both her eyes done. And I think she took a day or two off of work, and that's all she needed. And her vision was basically legal, allowed to drive after a couple days, and she returned to her normal working duties. So it's that was not the case back when I was a kid, like 20-25 years ago. You could be off your feet for a week or more, basically letting things heal and whatnot. So that's pretty cool. So I have a cool little video that I pulled out of my archives here on laser eye surgery. It's an older video, but I encourage you to watch that. It's about a 5-minute video as well. Okay, and then this is cool. I thought this was really neat here. Night vision goggles. I know with the gamers in the crew here, you probably have come across this in some of your video games. Um, Really what happens here is that we've got dim light, of course, so it's not very energized. It's very weak light. And what it does is it hits this plate here. So it comes through and it's going through a lens, and it comes and hits this plate. And this image actually, it's a photoelectric effect, I believe. It actually shoots electrons across, and it comes across straight. So whatever image is formed here is actually the same image that forms here. And then it accelerates more electrons, and they are released as a stream, and then eventually form this image on the screen. And of course, it's this phosphor coated. So the reason it's showing up green is it's phosphor fluoresces green, and so when it hits the screen, it glows green. And so that's what a person's going to see, is this glowing green image. And there's an image here that kind of gives you an idea of what it looks like in actual use. But it's really cool. So light is focused onto this image intensifier. The light energy releases a stream of particles, electrons that hit phosphor-coated screen, and then they glow green. And basically, that's all I expect you guys to know. It's just that it's intensified. It takes a very dim image and it actually makes it brighter using this technology. It's pretty cool tech. And there's a similar technology called thermal imaging. If you've seen movies like Predator, where you see Predator, it kind of sees the people on the ground. They're kind of glowing different shades of orange, red, and yellow maybe. What you're seeing there is thermal energy, and basically it's very similar to this technology with night vision goggles. The only difference is that the lens in those kinds of cameras are focusing infrared lights that are emitted by all objects, not visible to the human eyes, but we do sense it as heat. For example, if you were looking at an image of a hot pot of or a cup of coffee or something like that, you would feel the heat off it, but a thermal imaging camera will actually see it as probably yellow or orange or red, even depending on how hot it is. And so this infrared light is scanned by an infrared detector. It's computerized, and it determines or develops a temperature pattern that's called a thermogram. You may remember that term from Science 7 last year when we talked about the thermograms in terms of imaging homes to see where heat loss is coming from. And so basically your intensity of the infrared light gets transformed into red for really, really intense light, infrared light to orange, to yellow, to green, to blue, to violet, and violet would be the least of the intensities of light. Of course, I guess it could go all the way to black. Black would be absolutely no intensity of light. So yeah, some pretty cool technology. Again, I have a quick little video clip here. It's close to 3 minutes on how does night vision work. I recommend that you watch that one. It's really neat. And this, I have another video here. It's very much optional. It's about a half an hour here, and it reviews the concepts about the eyeball and vision that we've covered in the last 2 lessons. It's done professionally by Alberta company. I think it was Alberta Learning that did this back in the 90s sometime, if I remember correctly. So it's quite old, but it is very good. It's just we won't take the time to watch it in class, or I won't assign it to you for duties this year either. All right, so just to finish up, you guys, you need to be able to describe the function of eyeglasses today. So basically, you need to make sure you understand that for eyes that are focusing the image either in front or behind the retina, that the eyeglass is to adjust the refraction of light going through the eye so that it ends up focusing on the retina. You'll need to be able to describe when to use a convex and when to use a concave lens. So for people that are farsighted, we want to bend the light faster, if you will. So we need to use a convex lens when we're talking about farsightedness, and then a concave lens when we're talking about nearsightedness. And then just describe basically what I talked about here, and you can look in your notes about how night vision goggles work. I'm not looking for great detail here, just an understanding of the basic process. So if you refer to your notes that I've provided, that is the limitation as to what you need to know there. All right, you guys, that is it for today. You guys have a wonderful day, and I'll see you when I see you. Take care, you guys. Stay safe. Bye-bye.